Friction brakes. In this presentation, we're going to be looking at the parts and components of a friction brake assembly, its concept of operation, applications, common control circuits, and finally some summary points. In order to build a friction brake assembly, we need these three main components: some form of a brake drum, brake shoes which would press against the brake drum to apply friction and therefore slowing of speed, and finally a solenoid, which is an electrically operated component which is simply an electromagnet. When we energize the solenoid with its rated voltage, the electromagnetic flux draws the plunger down in the same way that a doorbell functions or a standard automated valve or even the basis of a relay movement. All of these items are then placed together into an assembly that allows for both of the brake shoes to move at the same rate and at the same time. There's a few pivot points at the bottom. The plunger moves up or down, and it's connected to the main connecting rod, which goes across the upper assembly. This is what allows for both the brake shoes to move at the same time. And then we have a main spring. Now, the main spring could be in various different locations, but this image works very well because it is shown obviously outside of the solenoid and very easy for us to understand. The mainspring is what provides the braking force onto the brake drum. And of course, the brake drum itself is connected to the motor's rotor. So as the solenoid plunger moves up or down, will then depend, or will determine rather, if the brake shoes are clamping or held away. When the solenoid is energized, the brake shoes do not touch the rotor, and this allows the motor to spin freely. So at this point, the solenoid position is compressing the mainspring, and this is what holds the brake shoes away from the braking drum. When the solenoid is de-energized, the brake shoes clamp the rotor due to the spring tension and hold it stationary. So the solenoid releases the main spring, and the main spring is what presses the brake shoes against the braking drum. In this way, when the motor is running, we have the three-phase stator of the motor energized and the braking assembly solenoid energized. When we are applying friction braking, both the the stator winding of the three-phase motor and the solenoid of the friction brake are de-energized. And so in this way, friction braking is considered to be a 0 or 100% type of braking force. There are many different iterations of this and forms. We have friction disc brakes as well as friction drum brakes. We have separate friction brake assemblies that can connect onto any motor, and we have friction brake assemblies that are built into motors, typically with a handle release that allows for any form of maintenance to take place. Because remember, as soon as you de-energize that brake, it clamps the rotor. We see friction brakes on cranes, winches, elevators, hoists, all over industry. Here's an example of a dual caliper disc friction brake. And finally, an overhead commercial garage door friction brake. There are two different circuit connections that friction brake solenoids can be supplied from: control circuit or power circuit. For a control circuit, the solenoid is supplied power from the control circuit voltage. So perhaps the control circuit in this diagram is 120 volts, and the control circuit is then driving or powering the brake solenoid. We can see here that as soon as the start push button is pressed, both the main motor starter power contacts are opened at the same time, closed, at the same time as the solenoid is energized and releases the brake. The other form, which is, depending on the application, perhaps more common, is the brake solenoid being powered with the rated voltage in the power circuit. In this way, we don't have to run more conductors out to the control circuit. Instead, the supply for this solenoid, which remember is right beside the motor because this is where the rotor is placed, are only going to be a few feet because I need to get power from the motor connection box over here to the solenoid. And this will only be energized when the motor's energized because of the power contacts in the power circuit. So when the motor is de-energized, the brake solenoid is de-energized, and that guarantees that there will be no rotation. Friction braking is the only braking system that ensures the rotor cannot move after it has been brought to a stop, and it's not for every application. So friction brake systems are typically used as an on-off type of parking brake. They're not typically used to slowly reduce the speed of a rotating shaft. They are energized to release the rotor, allowing rotation, and they're de-energized to clamp the rotor, preventing rotation. They can only be used, they can be used on any type of motor, and 100% braking force is applied when the motor is stopped. Now, other braking systems are designed a little bit different than what we've looked at here. And these braking systems are designed to smoothly and quickly stop a motor, not just provide 100% stationary holding power.